Hey class, if you're watching this video, that means you were not able to make it to our review session today, so that's unfortunate. We didn't get to touch base and see each other. But anyways, I hope you guys are doing well. It's Friday, right? After today, we just have 3 more lessons, right? We got next week, and then that's kind of the end of the school year. So today, we were talking about more simplifying with radicals, all right? So again, you might want to print these notes out so you can follow along. And then so you can be able to do the practice problems afterwards. All right, so here we go. So yesterday, right, we talked about this multiplication property of square roots, right? We took this one radical and we were able to break it apart into a perfect square number times a non-perfect square number, right? So that's the multiplication property of square roots. All right, but along with this multiplication property of square roots, right, it also works the other way around, meaning I can take 2 radicals and I can multiply them together and turn them into 1 radical. And then kind of repeat the process, right? Because the whole idea of simplifying radicals is to get it in the simplest form, right? And to get it into the simplest form means we got to take out the perfect square. All right, so today's lesson is more on multiplying radical expressions, meaning there's going to be more than one term in here. All right, so to do this, right, we want to multiply numbers on the outside of the radicals together and multiply numbers on the inside the radicals together, right? So the out with the out, the in with the in, all right? And once we do that, then we're going to follow our normal steps for simplifying radicals by finding that largest perfect square factor of that number. All right. Oh, look who's here, right? I think you know this guy, right? This is the Hulk, right? And what does the Hulk like to do? He likes to smash, all right? So that's kind of like our first step here when we're multiplying radical expressions, all right? So we're going to smash these 2 radicals together, right? We're going to take that rad 6 times that rad 10, and we're going to make it into the rad 60, all right? And that's what we're going to do to all our radicals. We're going to just smash them together, all right? So that's our first step, is to multiply these radicals. All right, and after that, we're going to follow our same steps to simplify these radicals. All right, and that is breaking up the radical expression into the product of a perfect square and another factor. All right, so this rad 60, right, is going to get broken up into the rad 4 times rad 15. All right, and I want to do that because this rad 4 is a perfect square factor. All right, and I couldn't do that to start with because I don't have a perfect square inside of rad 6 and I don't have a perfect square inside of rad 10. So therefore, I need to bring them together first and then break them apart. All right, and once we break apart that radical into a perfect square number times another factor, right, then I can just simply simplify the perfect square number, right? The square root of 4 turns into 2, and this rad 15 just stays as a rad 15 because it is not a perfect square, and there is no more perfect square factors inside of 15. All right, so again, here are those lists of those perfect square numbers, right? These are the numbers that we need to find inside the radical if they're there. All right, so let's do these practice problems. All right, we're going to completely simplify the following radical expressions. All right, completely. All right, so we have rad 3 times a rad 6. All right, that means we're going to smash these together. All right, and make these into a rad 18. All right, now that I have my rad 18, now I'm going to break it apart. All right, but it's going to be a perfect square number times a non-perfect square number. All right, so again, to find that number, right, we're going to take that 18 and we're just going to divide it by one of these perfect squares. All right, well, it's not going to be 16, so I'm going to try 9, and 18 divided by 9 is 2. So that means this rad 18 is going to simplify into the rad 9 times rad 2. And this rad 9 here is my perfect square factor. So that rad 9 is going to simplify into 3. And this rad 2 just stays as a rad 2. So then my simplified answer is 3 rad 2. All right, and number 2 here, right, we have a rad 2 times a rad 10. So I'm going to smash those together, and I'm going to get the square root of 20. All right, now that I have my square root of 20, now I'm ready to break this apart into a perfect square times a non-perfect square. All right, and again, to find that perfect square number, you start with 20, and we're just going to divide down the line here to find the largest perfect square factor of 20. All right, well, 16 is not going to go. I know 9 doesn't go into 20, so we're going to try 4. And that's right, 4 times 5 is 20. So that means my square root of 20, I'm going to break up into the square root of 4 times the square root of 5. Right, the square root of 4 is a perfect square. So that square root of 4 turns into 2, and this rad 5 just stays as a rad 5. So then my final solution is 2 rad 5. All right, number 3, all right, the same way, right? We have the square root of 5 times the square root of 12. All right, we're going to smash those together or multiply those, and 5 times 12 will give us 60. So then I get the square root of 60. All right, then now I'm ready to break up this rad 60 into the square root of 4 times the square root of 15. All right. And again, to find that 4, it's because I took my calculator and I took 60 and I just divided it by these perfect square numbers to see which is the largest one that goes into it. All right, and 60 divided by 4 gives me that 15. All right, so now that I have that, right, the square root of 4 is my perfect square, so that turns into 2 rad 15. All right, not too bad, right? All right, let's got some more problems here, all right? So now on number 4, right, we have 3 rad 3 times rad 8. All right, so if you notice on number 4 here, right, I have a number outside my radical. But I also have numbers inside my radicals, all right? So when I smash these together, right, any numbers on the outside is going to stay on the outside. Any numbers on the inside are going to be multiplied together. So this 3 is simply going to stay on the outside. So this turns into 3 rad 24, right? Because 3 times 8 is 24. All right, so now that I smash these together, now it's time for me to break them apart. All right, so again, I'm going to break up this rad 24 into a perfect square number times another factor. All right, and this 3 kind of just stays on the outside, right? Since this is all multiplication, right, it just kind of stays outside, and I'm going to multiply that 3 here at the end with something else. All right, so again, I have my 24, and I need to break it down. All right, so I got to find my perfect square that's a factor of 24. Well, if I look at this list, right, the only number that kind of makes sense to even try is going to be 4. And there it is, right? 4 and 6 are my factors that I'm going to use. So I'm going to say the rad 24 is going to break down into rad 4 times rad 6. And this rad 4 is my perfect square factor, right? And that simplifies to 2. And then I have 3 on the outside still times 2. Now is not on the outside, right? It's not on the radical anymore. Times this rad 6. All right, and then I can just simply multiply 3 times 2 to give me 6. And that rad 6 stays as a rad 6. So then my final simplified solution is 6 rad 6. All right, again, there's multi-steps involved there, but you do it one piece at a time. All right, smash them together, break them apart, and simplify. All right, so number 5 says we have 4 rad 5 times 2 rad 10. All right, so again, we have numbers this time, 2 numbers on the outside. Well, I'm just going to multiply those together, right? Because they're on the outside, they're just numbers. So 4 times 2 gives me 8. And I also have numbers inside my radicals, right? So rad 5 times a rad 10 is going to be a rad 50. Right, my outside with outside, inside with inside. All right, so once I smash these together, now I'm ready to break them apart by finding that largest perfect square factor and another factor. All right, so I'm going to break up this rad 50 into a perfect square times a non-perfect square. All right, and like I said, this 8 just kind of stays on the outside for now. You got to make sure you kind of bring it on down. All right, so I'm going to take that number 50. All right, I'm going to see which of these perfect square numbers can divide evenly into 50. All right, and the only one that kind of, again, makes sense is going to be the 25, and it's 2. All right, so that means this rad 50, I'm going to break up into rad 25 times rad 2. And now I'm ready to do some simplifying, right? Here's my perfect square. That turns into a 5. This 8 is going to come down. Now I'm going to use this 8 times 5. I'm going to keep that rad 2 as a rad 2. Right? 8 times 5 is 40. Rad 2. My completely simplified solution here. Awesome. All right, we got 2 more to do here. All right, hopefully this is making sense. All right, number 6, we have 2 rad 3 times 3 rad 11. All right, so again, I have some numbers on the outside. 2 times 3 gives me 6. And I have some numbers on the inside, right? Rad 3 times rad 11 is a rad 33. All right, so now that I'm smashing them together, I'm ready to try to break them apart. All right, that means I'm going to try to break up this rad 33 into 2 factors. All right, so let's see, what can I break up 33 into? 33 divided by, well, 36 is too big. 25 is not going to go. Oh, 16, right? No, wait a second. That's 2.06. That doesn't work out. 33 divided by 9? No, that doesn't work either. How about 4? 33 divided by 4. No, 30. No, that doesn't work either. So that means, right, sometimes a radical cannot be broken down anymore because there is not a perfect square factor of it. So if that's the case, right, I can't simplify anymore. And that rad 33 is just going to stay as a rad 33. So that means this is my simplified solution, right? This is as much as I can do with this problem, right? 6 rad 33 would be my completely simplified answer, completely. All right. And my last one here, number 7, I have 4 rad 6 times 2 rad 6. All right, again, I'm going to take these outside numbers, right, numbers outside the radical. I'm going to multiply those together. So 4 times 2 gives me 8. And I'm going to take this rad 6, and I'm going to multiply it with another rad 6. And 6 times 6 is 36. Oh, wait, that number looks super familiar. Let's see. Oh, there it is. Rad 36 is a perfect square. All right, so if that's the case, all right, and sometimes that will be the case, right? This rad 36 is a perfect square, so that simplifies to 6, right? And I have this 8 on the outside, so I'm going to bring that down, all right? And they're next to each other, right? So that means I'm multiplying. So this really turns into 8 times 6, and 8 times 6 gives me 48. So that is my simplified solution for number 7 here, right? It's just 48. All right, in this case, my radicals, when I smash them together, turn into a perfect square number, and I'm able to completely get rid of that radical if it's a perfect square number. All right, so hopefully this makes sense. And now you guys are ready to try the practice worksheet. All right, might as well just get it done now. This way you can enjoy the rest of your weekend, and we'll be back on Tuesday to do one more week of math here. All right, keep it up.